All right, shall we get started? Hello and welcome to this talk about Jubula. It's a beginner's talk about Jubula and the ITE. As a short introduction, my name is Markus Tiede. I'm working for the Bredex GmbH, which is located in Braunschweig, Lower Saxony in Germany. I'm a committer on the project since the first days, which is 2011. I'm the technical project lead, and last but not least, I'm also the package maintainer for Eclipse for Testers, which is the Eclipse package for Jubula. By the way, are there any actual Jubula users currently present, or are you all new to Jubula? Who's already tried Jubula, using Jubula? Okay, great. So basically all new and want to familiarize with the tool. So you're perfectly right in this talk. As an agenda for the next 30 to 35 minutes, I'd like to give you a short introduction to Jubula and basically focus on the main concepts of our tool, which is how do I specify tests, how do I connect my tests with the application under test, with the AUT, and how do I execute tests. All of that while doing ongoing demonstrations, like live demonstrations. And after that, after covering the basics, I would like to show you some of the advanced topics, like handling events that might happen during test execution, integrating Jubula and Jubula tests into your CI environment, and also connect Jubula to arbitrary ALM systems. What's Jubula? Jubula is an Eclipse project, and we're doing UI testing, like user interface testing, graphical user interface testing. And we often refer to our tests to test not the UI, but through the UI. Like we actually enter through the whole application stack down to the database systems, the application servers that lie behind, that actually often hold the logic. We execute tests in a way that's very close to manual tests. So we actually perform real clicks within the application and within the screen. So we actually cover, by using the UI, all of the layers of the application. And with Jubula, you basically automate complete workflows within your applications. For 10 years now, like since 2011, we're hosted at Eclipse as an Eclipse project, but actually it started out as a commercial product in 2004 and 5, which is formerly known as Guidancer. And since 2011, it's been hosted at Eclipse, and it's now completely feature identical. And right now in this talk, it's the last time that we use the name Guidancer for the tool. So it's officially deprecated, and we're not going to use this anymore. Our approach is we are automating tests for the user interface by using a code-free approach, by simply using keywords to specify your tests in. And the application itself we refer to as a black box. So you don't have to know anything about the application apart from maybe the toolkit you're using. Speaking about toolkits, we support a couple of them. Like in 2004 and 5, we started out with Swing. At that point in time, we had the problem that we couldn't test ourselves because the ITE, the integrated test environment, we are often also calling Jubula, itself is written in SWT and RCP. So we added support for that in 2006 and 7, so that we can actually test Jubula with Jubula. We also cover Jeff, the graphical editing framework, as a toolkit. We added HTML and iOS as a toolkit support. And during the last 2 years, we've been focusing on adding support for JavaFX and AFX Eclipse support within Jubula. And with Jubula and the Jubula ITE, like the integrated testing environment, our main focus lies on non-technical testers. Which means we've always tried within the ITE to focus or to combine the best of both worlds. To have like concepts from the programming world to structure and decouple your test specification from the application, but also put a non-technical person into the ability to automate tests for the user interface. So basically this is what we're aiming for with our tool. And we do that by using a keyword approach. And right here you see a test specification within Jubula. It's for the Create New Java Project dialog. I think that you are all familiar with from Eclipse. And it's basically a structure, a tree structure, where you can reference test cases. And test cases are these little orange modules over here. You can reference them in different contexts. All right? So for example, if you want to select something from the menu bar, you simply give it a meaningful name. That's basically how you write tests. And put this into a reusable module that you reference at different places. So for example, if you want to click on a button, for example, you can build yourself a small module that you reference 2 times, where you, for example, first synchronize that the button already is already there or appears, then check its enablement, and last but not least, click the button itself. And in this case, for example, it's done for the click next and for the click finish button. All right? And with this dependency tree of referencing test cases, you basically specify tests within Jubula. We also have a basic concept for parameters. You can also see it here, like important data that basically drives your tests. You can add it as an interface, like a parameter interface to a test case. We will see that in a second how that works. Like in this case, it's often the project name. Maybe you want to loop about and create a couple of projects, or the enablement of buttons and so forth and so on. Within this test specification, who already knows the famous simple adder that we're always referring to in all of our examples? Anyone familiar? Okay, I'm going to explain it just in a second. It's a very basic application that simply adds up 2 values. So you've got value 1 text field, value 2 text field, a button to invoke the addition of the 2 values, and a result text field. And imagine that you've got an application like that and a test that basically refers to an already specified module that's capable of replacing the first text, the second text, the calculate, and the check text. Within your test specification, you use arbitrary identifier for the fields that will be available within your AUT. And within a step we call object mapping, you connect the arbitrary identifiers from your test specification with this application on a test, and make your test executable by that. We will also see that in a second. And this object mapping is basically coupling your test to the application, which might also be written in a totally different toolkit. Okay? And the last concept I would like to give you a short introduction to is our test execution. We basically support all major platforms, like we're focusing on Windows, but you can also run your tests on arbitrary Linux platforms and even macOS, though we have recently not been focusing on that. As I've already mentioned, the tests themselves only get coupled to the application itself by its toolkit and by the mapping, and thereby we support a whole bunch of UI toolkits that might actually be available or present within the AUT's UI, like JavaFX, EFX, Eclipse, SWT, RCP, HTML, Swing, iOS, and so forth and so on. You can even write and add support for your own toolkits within Jubula. We've got extension points for that. And you can execute your tests across the network. We've got different components within Jubula, which I will introduce in a second. like the AUT agent, which is actually handling the lifecycle of your application under test. And you can launch this AUT agent on the same machine, like we were going to do that today, but you can also start it across the network and connect to it remotely. All right, so I would like to give you a short introduction to the ITE, the Integrated Testing Environment of Jubula. Who's already seen this? This is basically it, the ITE and RCP application with a couple of views. And what I would like to do first is I would like to load a project. And projects within Jubula contain all of the test specification, all of the object mapping, all of the data. And the projects are stored in a central database systems. We are using for demonstration purposes the H2 instance, but you can also use MySQL or Oracle instances. So I'm loading our official samples project. And I would basically like to show you one of the basic views we have. Because the test specification is happening in the test case browser. That's the place where you're managing all of your keywords, all of your modules, all of your test cases. And you reference them into the context of a test suite, and then you can actually execute it, the test. So I would like to show you one part of the test specification we've already seen. A simple adder test, which is entering two values and clicking a button. All right, I've already specified that. You can add data, you can add component names, and have a signature also to loop over data sets. And I would like to execute this test now. And to do that, I'm right now using the embedded AUT agent. And to connect, actually there's currently no AUT running. To connect to an AUT agent, you simply choose it from the toolbar menu and say connect to a dedicated AUT agent running somewhere on the network, or simply using the embedded AUT agent. So I'm doing that, and as soon as I've done that, I'm able to start AUTs. AUT, the application on a test. The sample project comes with a couple of them, and today we're going to use, in this demonstration, a Swing application. And I'm going to briefly show you what an AUT configuration contains. Like you can define multiple AUTs within a project. And for a given AUT, you simply say it's a Swing application, for example, and it's launched by your jar, which is using this working directory, the default Java, which is available in your environment, and so forth and so on. So you basically specify that once within the project, and then you can launch up the AUTs process. So as soon as that's there, as soon as that's there, I would like to first of all show you how a test gets executed with Jubula. And there's this first test suite that references this test case. And I'm able to execute this test suite on this AUT. All right? So what's happening right now is we're establishing a connection to the application. It's been instrumented by a couple of remote controlling capabilities that we need to actually inspect the widget tree. And we're looping over a data set of 4 to replace some values and driving the application. But right now, we're not actually testing. Does anyone know why?
Because we don't check for the result.
Exactly. We don't check the result yet. So I would like to change that. And I'm going to search for this module. I want to open the specification of this module. Okay? So we also got this editor concept where I can now change the content of this keyword. And I would like to add a verification or a checkpoint to actually check that the addition result is correct or not. I can do that by either knowing which test step I need, or by simply browsing our predefined, we call it Unbound Modules library. It's a decoupled library for test execution steps. And there are some things for checking, some things for checking arbitrary components that might hold text. which is also toolkit independent. And there's a module, check the text, and I add it to the end of my test specification simply by dragging and dropping it to the editor context. And right now, I need to enter a couple of information. I need to tell the test what's the expected value, all right? And we already see that our test holds in its signature, in its parameter signature, 2 parameters, value 1 and value 2. And I would like to say, okay, the text in this case is also a part of this test's parameter signature. All of the comparisons I would like to do in an exact way. You can also use regular expressions or simple matching. And this is the logical component identifier I'm using during my test specification. So I have to actually give this component a name from my perspective, which is independent from the real UI implementation. So I'm going to call this result Eclipse con. And as soon as I save this test case, we should notice a couple of problems within our project. Because actually, now we've got something, we've added a new parameter, but we haven't ever specified what kind of data it should use, except from it should get it from a parameter of the test case. And we have an incomplete object mapping. And we're going to take a look at that now. So within a usage point or reference point, the data for this result is missing. Okay? We've already seen a small test execution for a data set, like 3, 3 equals, let me do the math, 6, 0, 0 is 0, that's 2, and that's 3, all right? So if my data complete, and the last thing I've got to do is I've got to complete the object mapping, all right? For that, I've got to start something we call the object mapping mode. It's in the main toolbar, and you say, I want to object map for this AUT. And if you're in this mode and the application got started by Jubula itself, you will notice this slight green borders when I now hover through the application. Okay? And if I now press a special configurable key combination, which is by default Control-Shift-Q, I'm collecting this widget, the supported widget, from the application's UI. And as it's already been used in a couple of different test specifications within this project, it simply says, okay, I've got a mapping from other logical identifiers within this project, and I'm simply assigning my new logical identifier to this collected component, to the subtext field. And as soon as I've done that, my test should be executable. All right, so as soon as I'm now executing this test, we have a verification point added to our test specification. Yeah, I'm taking questions at the end. Is that okay? Okay. So you basically see we're now looping with four steps being executed at one time. Okay, so you've got this live tracking of the execution, which is pretty handy if you execute your tests across the network on a dedicated machine or virtual machine. So this is basically a brief introduction to the ITE. We've got tons of more concepts, like it's a tool that's been growing over 10 years now, but that should settle for now for a brief introduction. Now, if you've got a test like that, you want to run it as often as possible. Yeah? You want to run it in your CI system, in your Hudson, in your Jenkins, in your whatever you're using. So I'd like to, instead of focusing on the ITE, put the ITE aside for a bit for now, and focus on the other tools that we provide with Jubula, that come with Jubula. Like we already talked about the AUT agent. It's handling the connection to the AUT, managing the lifecycle. And we also got a tool dedicated for command line usage and continuous integration. It's the TestExec. Okay? TestExec comes with a bunch of parameters that you've got to enter. We're going to take a look at that now. And you can from whatever continuous integration system that supports invoking of external commands, you can basically execute Jubula tests. Okay. So for that, we switch to the command line. And this is the command that's going to be, that's the command that's going to be executed in a second. It's not readable. Oh, I'm sorry. Can you read it now? I never did that. First tab? I think the problem might be the color. This is okay? Somehow readable? I didn't. Okay. So it's basically pretty simple. We say, okay, TestExec. We specify the location of our database instance. It's the H2, as we said. We say use an AUT configuration to start up the application. Its name is this. We've got an empty database password. The DB user is SA for the embedded database. We say we want to execute our tests in ANUS language. It's a samples project in version 8.2, and the result directory is on my desktop. And we want to execute the test suite that's named 2-TestExec. All right? So that should happen right now. This command now gets executed. And all of the components that are necessary are being started in the background. The TestExec, if not specified otherwise, uses an embedded version of the AUT agent. So it's loading all the data, checking its completeness of the project and test specification, connecting to the AUT agent, loading the project, connecting to this AUT, which might also be running across the network, and we're entering a slightly different test. I used a different data set for this, and whom of you know this simple adder? We've added a small bug to that, where we should now find within the test results that are getting written to the file system. It's a test result report. It's containing all of the necessary information. And it's also taking, for example, screenshots if unexpected situations happen within a verification point. And over here, we try to add 17 and 4, and it doesn't equal 21, but jackpot. So Jubula noticed that, documented that, and continued with the test execution. Okay, so this should be it for the TestExec and event handling. All right, so we've seen our first event within a test execution. And we've got a pretty complex system for handling arbitrary events that might happen while executing your tests. Because, as I said at the beginning, we are focusing on remote controlling or specifying tests to model complete workflows through your UI of the AUT. And you, for example, basically often start with automating different use cases. All right, they're all kind of having some kind of a setup methods that brings your AUT in a certain state, then do the actual testing, and then tear down your test again. Okay, and without having the ability to handle some kind of expected difference between the actual state of the AUT, you would end up, for example, executing tests in the long term you would always be in the state that the expected amount of test steps that you might want to execute never meets the actual executed amount of test steps, because from time to time the one use case fails, the other use case fails, and as soon as the first use case fails, the second use case test didn't get executed because you basically quit your test execution. And that's why we have an event system that's dynamically evaluated during test execution that allows you to do different, or to cover different scenarios. For example, within a workflow 1, if you get an assertion failed, or in Jubula it's called a check failed exception or a check failed error, you can either decide to handle it locally with a local event handler, or if an assertion fails, you can, by specifying different types of return types, like how do I want to continue at this point that the verification failed, you can say, okay, I'm going to handle this locally and continue, or I'm going to quit this test execution and continue with the next. All right? And I would also like to give you a very quick introduction to event handling during test execution. And for that, like you're now already familiar with the small bug that's built in the simple add-on, I want to show you a slightly different test specification. They're all using the same modules, only focusing on different aspects here. We're going to execute the simple adder test now with an event handler. And event handlers are basically pretty normal test cases that are called in the course of an event. Like this one will be called as soon as, a check failed occurs. Okay? And the logic of this event handler is doubtable, because what will happen is, in the case of a check failed event on this level of referencing, we will simply try to switch the parameter we enter. So we simply, instead of entering 17 and 4, we want to enter 4 and 17. And in addition to that, this test case is a event handler that's specified as a re-entry type of retry, which means if the test specification succeeds after this interaction, the test passes normally. You can handle unexpected scenarios with that within your test specification. So if I now execute this test, we should see that we enter 17.4, that some event occurs, we switch the sequence, unfortunately it's now clear, we switch the sequence and check the text again. Shall I execute it again? Maybe it's a bit too quick. It's first of all detecting the problem. 17.4, not a good checkpoint. 4.17 is okay, and the test passes. All right? You can do like exits. You can continue, like we've seen with the TestExec. We simply continued there when the error occurred. All right? So this is also just a brief introduction. And last but not least, if you've got now like a couple of tests set up, you've got your CI set up, you're handling test execution events in a way so that you can get test results per use case every night, for example. We also got a pretty handy application lifecycle, it's a very heavy word, application lifecycle integration in Jubula, which basically means that you're able to, first of all, link your test specification with requirements from different ALM systems, like for example Bugzilla, Jira, Track, or even HP ALM, for example. And in case of executing, when you execute these tests, you can report back the results to the ALM system, either by, for example, creating comments. I will also show you this very briefly within the ITE. Each project is via Mylin connected to arbitrary task repositories, and you can basically say, okay, I want to, in the case of a successful or failed test, I want to have a comment in my ALM system, or you can also add certain kind of rules to change specific attributes within the ALM system. For example, update certain kind of attributes and reopen a bug, for example, or close a bug. Okay, so this is ALM integration in Jubula. A very brief overview. I can't demonstrate, unfortunately, because the Wi-Fi is pretty unstable. So as a quick summary, we have the ITE, which you've seen over the last 30 minutes, which is for non-technical person. We've got a rich and grown feature set for the whole test automation process. We also got since Mars, and I already talked about that an hour ago. We've got a client API, which might be interesting for you guys who are basically or often developers. We've got an API to drive the AUT by. We can do what I just did via Java code and arbitrary test execution frameworks like JUnit or TestNG. And I think there's also a lightning talk of a colleague of mine in 20 minutes in the Bürgersaal 2. So don't miss that if you're interested in that. What's coming the next version for Neon? We are currently focusing on performance improvements within the ITE. And we are trying to also support, as we've got a centralized database system currently in the background, we're trying to focus to add support for distributed working scenarios. So that's what's coming for the next year. And we're also trying to keep up with the changes in JavaFX, because there have been quite a lot in Java 8. And also some minor evolutions within the client API. We are planning to add an embedded AUT agent also for that environment. All right. Now would be time for some questions. Got some? Get Jubula from the Eclipse page or from testing.predix.de, a complete setup with all of the example projects that we can distribute over the Eclipse installer. Yeah?
Just generally, object mapper.
Yeah.
How does it work? Will it work on any web page, for example? Are there any requirements in the software to make it work?
Requirements in the software, no. Web pages are special. We could talk about that in a second if you'd like. Yeah. Basically, for HTML, we are using Selenium. Okay. So, and we are injecting some JavaScript to get the component identifiers from that. Any other questions? Yeah.
In the example where exchanging the values, if the output would also have been jackpot, would it infinitely loop?
No, we've got a recursion detection, and the retry event handler, that's the only one that's looping up to a certain amount. It's got an upper limit, so you can actually hit a infinite recursion. Okay, so please think or rate this talk if you liked it. If you not liked it, please leave some comments, and that should be it for now. Thanks.